Hey guys, happy Monday. You should already have finished the warm-up. Homework was, there's no homework over the weekend. So this should be already completed. This is a review from Friday. So if you forgot over the weekend, look back at your notes on Friday. We're going to go over this shortly. So give you another minute or so, and then when Miss Osborne sees that everyone's pretty much done, she'll push play. Okay, so if I want to solve this inequality, remember we talked about inequalities have a symbol that doesn't represent equal to. It's either not equal to, greater than, less than, or less than or equal to, greater than or equal to. So we talked about that, and it's the same exact way as solving equations, except there's one little thing we have to remember. So when we get to that point, hopefully you guys have remembered that little trick, and we're very cautious about it. So if I want to isolate the variable x, I'm going to take away 12 on both sides, which means I'm left over with negative 6x is greater than or equal to 10. From here, I need to get x by itself, so I'm going to divide by negative 6. And remember, we talked about this on Friday. When you divide by a negative number, what do I have to do? Hopefully you remembered, you have to flip the sign. Divide or multiply by a negative, I have to flip the sign. So I went ahead and flipped it. And now 10 divided by negative 6 is negative 1.66 repeating. If you kept it as a fraction, I can simplify that, cut that in half, so 5 over negative 3. Either one of those is correct, but you have to make sure that you flip the sign if you divide or multiply by a negative. So today we're going to do more of that, but now we're solving multi-step inequalities with variables on both sides as well. So on the next page of your journal, this is actually 1-6 in your homework hotspot book, so if you need more examples when you get home tonight, you can look in your homework helper book, and this is 1-6. Today we're solving multi-step inequalities. Today is September 12th. This is my page 25. I'm going to go ahead and label my table of contents. So when it comes to solving multi-step inequalities, this is the same exact thing as solving multi-step equations. Just like what we did on Friday. It's the same as solving multi-step equations. But we have to remember that trick is we have to flip the sign if we multiply or divide by a negative number. So again, it's the same thing as solving multi-step equations, but we have to flip the sign if we multiply or divide by a negative number. So just to refresh our memory about the steps. Steps to solve any multi-step equation or inequality. First thing we need to look for is if there's parentheses, what do we need to do to simplify the parentheses? Okay, we have to use distributive property. Remember, distributive property is when I have a number outside of a set of parentheses with two terms on the inside. Since I can't combine these two terms, I need to distribute or multiply that 3 times everything inside of those parentheses. After I simplify and get rid of the parentheses, the next step here is I'm going to combine my like terms. Again, a like term is what? Like term has the same variable with the same exponent. We have to look at if they're on the same side. So I'm looking on the left side. Is there anything I can combine? Then I'm looking on the right side of the inequality symbol. Is there anything that I can combine? Once I'm done with that, I have to look for moving the variables to one side. Doesn't matter which ones I move, doesn't matter which side I move them to. I just have to get all my variables to one side. After I'm done with that, then I'm going to move my numbers, or my constants, to the other side. So I have my variables on one side, and then my numbers on the other. And I'm going to then isolate the variable. Again, put your triple star, flip the sign if we multiply or divide by a negative number. Again, we're going to have this written down probably 20 times in our journals. That's huge. Because we know how to solve everything, it's just we can't forget that little step. Go ahead and put a highlighter box around these steps, because this is what you're going to be looking at for your homework tonight. And then we're going to get after it, because again, this should be somewhat of a review, because we've already worked on solving equations, the same thing, except we have to remember the flipping the sign. So let's get started. Let's solve 3 parentheses x plus 2 parentheses minus 6x plus 6 is less than or equal to 0. And we're going to look at the steps, follow step by step every single time to make sure that we're doing it the correct way. So step 1, distributive property. I have parentheses here, so I need to distribute that 3 to everything in parentheses. So I'm going to go ahead, I'm going to put number 1, first step, I use distributive property. I'm going to go ahead and write that. I want you to write that as well. So I just used a different colored pencil for each step. So again, once I distribute that, I'm going to rewrite everything I have. So 3 times x is 3x. 3 times 2 is a positive 6, and then I'm just going to recopy this negative 6x and the positive 6. The less than or equal to sign stays the same, and it's equal to 0. Okay, so now what do I do next? I'm looking at my next step. Can I combine any like terms on the same side? Well, if I look on the right side, nothing I can combine. What can I combine on the left side? So step 2 is I combine my like terms. So if I look, I have x's, so I can combine the 3x and the negative 6x. And then I also can combine the positive 6 and another positive 6. So when I rewrite what I have, 3x minus 6x is negative 3x. 6 plus 6 is a positive 12, and it's less than or equal to 0 still. Okay, step 3, move the variables to one side. Okay, are all my variables on one side? Yes, they are. They're on the left. So I don't have to do step 3. Step 4, move the numbers on the other side. So again, I want x by itself. I'm going to isolate that variable. So to get rid of this positive 12, we're going to subtract 12 on both sides. And I'm left over with negative 3x is less than or equal to negative 12. And then my last step here is I want to isolate the variable. So, to get x by itself, right now it's multiplied by negative 3. So I'm going to divide by negative 3. Now again, if I divide by a negative number, what do I have to do to that sign? I have to flip the sign, and negative 12 divided by negative 3 is a positive 4. So my answer here is x is greater than or equal to positive 4. I'm going to go ahead and put a double star here because that's where we wrote down what to do, and we had to flip this sign. So again, just following the step-by-step that we wrote down in our journal will be very beneficial. Let's try this one now. Let's have 5 halves x minus 1 is greater than 14. So, any distributive property here? No distributive property. Step 2, I'm looking up here, step 2 that we wrote down, combine like terms on the same side. Can I combine anything on the left side? This is an x, this is just a number, so no. Can I combine anything on the right side? No. So step 3, move the variables to one side. Are all my variables on one side? Yes. So moving on to step 4, move the numbers to the other side. So I'm going to go ahead and move the number not attached to the variable. So I'm going to add 1 to both sides. And I'm left over with 5 halves x is greater than 15. Now this is up to you on how you want to do this. I could multiply by the reciprocal on both sides. Or, again, I don't like fractions, I just change them to decimals. If I want to figure out what that decimal is, 5 halves is the same thing as 2.5. So I'm going to go ahead and write 2.5x is greater than 15. Since I'm multiplying the 2.5 times the x, I'm going to divide by 2.5 on both sides. Now, do I have to flip the sign here? No, because this is a positive number divided by a positive number, not a negative. So my answer ends up being x is greater than 15 divided by 2.5 is 6. X is greater than 6. Okay, let's just try a couple more. And then there's one more little topic we need to discuss before you start your homework. So you'll have some time in class to get that done. Alright, let's try negative 8 minus 3n plus 6n is greater than 12 minus 2 cubed. I want you to take a second to solve that using your steps that we wrote on the other page for your notes. And then when everyone's close to being done, check with your neighbor, and then Ms. Hausman will push play so we can go over the answer. Okay, if I'm looking at my steps, step 1 is distributive property. So, are there any parentheses on either side of the inequality symbol? No. So, step 2, I'm looking for, can I combine my like terms on each side? So if I look on the left side, it looks like I can combine my n's, the negative 3n and the positive 6n. I'm going to go ahead and rewrite what I have. Negative 8 just falls down. Negative 3n plus 6n is a positive 3n. Still a greater 2 sign. Now I can simplify this right here. What's 2 cubed? This really means 2 times 2 times 2. So 2 times 2 is 4. 4 times 2 is 8. Now the way that you enter that in the calculator, if you forget, is you push in the 2. And if you look at this little symbol, I call it a caret. You'll hear me say that a lot. It's above the divided by symbol. Push the caret sign and push 3. Now look what it does to your actual screen. It makes it, you can make any exponent. So it could be, we could do 2 to the 25th power using that caret symbol. Once I do that, I push enter, and it would give me my answer. Okay? So now again, I'm looking, that was on the left side. can I combine anything on the right side? Yes, now I can. So this is on my left. I'm still using that step 2, which is combining my like terms on the right. And I can combine the 12 minus 8, which in this case would give me just 4. So I'm going to go ahead and recopy everything I have down, again making sure I don't miss any steps. Okay, next step, move your variables to one side. My n is already on that side, so I don't have to do anything like there. Now I move my numbers to the other. So since I already have numbers on this side, let's move this negative 8. So I'm going to add 8 to cancel it out to 0. Add 8 over here, which leaves me with 3n is greater than 12. And the last step here is I divide by the coefficient of a positive 3. Do I flip the sign here? No. So it's still n is greater than 12 divided by 3 is 4. Now if I was to graph this, go ahead and take a second to graph this. So this was also from Friday. How would I graph that? Okay, I'm going to have 4 in the middle. We'll do 5, 6, 3, and 2. Is this going to be an open or closed circle? N is greater than 4 would be an open circle. And if n is greater than 4, it has to be everything to the right. 5 and 6 are greater than 4. Okay, let's just try one more before we talk about the last little thing. Let's do negative 6a minus 16 is less than or equal to 6a plus 8. Again, work this by yourself, and then when everyone's close to being finished, we'll go over it together. So, first thing, no distributive property. Second thing, can I combine anything on the left side? No. Can I combine anything on the right side? No. So my next step here is I want to move my variables to one side. So just to keep my variables positive, I have negative 6a over here and positive 6a. Let's add 6a over here to cancel that out. And I'm going to add 6a over here. I'm going to rewrite what I have. So I have negative 16 on the left side is less than or equal to 12a plus 8. Okay, and my variables are all on one side, so now let's get our numbers on the other. So I'm going to subtract 8 on both sides, which leaves me with negative 24 is less than or equal to 12a. Now, last step here is I'm going to isolate the variable. So right now it's 12 times a, so I'm going to divide by 12 on both sides, which leaves me with negative 2. Do I flip the sign here? No, because I divided by a positive number, not by a negative. So this still stays less than or equal to a. However, that's not quite correct because I need to rewrite it so my variable's on the left side. So it's opening up towards a, so I need to flip the sign when I rewrite it, so a is greater than or equal to negative 2. Now you'll notice that, say we divided by a negative 12, we would have had to flip the sign when we divide by a negative, and then we would have to flip it back to get the variable on the left side. So there could be times where you're flipping it 2 times in one problem because you divide by a negative, and then the variable is on the wrong side, so you have to flip it again. So just be aware of that. Okay, now the last thing I want to talk about again is our types of solutions when it comes to our inequalities, and it's again very similar to when we're solving equations. So there's 2 types of solutions here when it comes to inequalities. It's either going to be true or false. A true statement which that's what we've seen so far, that's going to have many solutions. Okay, everything that we've done so far with inequalities gives us something like this, where x is greater than 12. Well, how many solutions are there? It could be 13 is greater than 12, it could be 14 is greater than 12, it could be 100 is greater than 12. There's lots of solutions that go with this inequality. Or, if maybe their variables cancel out and it leaves us with 14 is greater than 13. That's still a true statement, which means that there's many solutions I could plug in for the variable that canceled out to make it true. The other type of solution is just a false statement. And this is when there is no solution. So I'm working the problem out, and then let's say I'm left over with 12 is greater than 15. Variables cancel out, and 12 is greater than 15. Is that true? Is 12 ever going to be greater than 15? No, that's false. I don't want to have $12. I'd rather have $15 in my pocket. So this would be a false statement, which would be no solution. Now when we're working out these inequality problems, we might end up having something like this, where I might have x plus 5 is greater than or equal to x plus 3. Okay? You don't know right now. Well, you might. Is I want to get x by itself, isolate x. What could x be to make this statement true? So, let's see. No distributive property. Can I combine anything on the left? Can I combine anything on the right? No and no. So now I move my variables to one side. So if let's say, take away this x, minus x, minus x. Well, x minus x ends up being nothing. So I'm left over with 5 is greater than or equal to 3. Now I'm done there. But is this a true or false statement? 5 is greater than or equal to 3. This is a true statement, which means that I can plug in any number for x, and it will still give me a true statement. So in this case, it would be many solutions. There's many solutions I could plug in to make that a true statement. Now, just because it has this equal to bar, still makes it a true statement, because 5 is greater than or equal to 3. It's greater than 3, so that's why it would be a true statement. Something that would look like a no solution would be this. 2x plus 6 is less than 5 plus 2x. See, if you notice, the variables are the same on both sides, which means they're going to cancel out. So if I take away 2x on the right side, 2x minus 2x again cancels out, which leaves me with 6 is less than 5. Is that a true statement? No, this is false. So in this case, no matter what value I plug in for x, it will always give me a false statement. There's no solution at all. There's no value for x that would make that statement true. Now I want you to try one hard one. This is the last thing we're going to do before you get your homework. I want you to try and solve this one. 2 parentheses 3n minus 2 minus 4 is greater than or equal to 3 parentheses 2n plus 7. Take a second to work on this by yourself or with the person next to you. Check your answers, and then when everyone's close to being finished, we'll go over it together. Alright, so if I follow my steps, going back to my steps, first step is to do the distributive property. So I have to distribute this 2 on the left side and this 3 on the right side. So if I rewrite what I have, 2 times 3n is 6n. 2 times negative 2 is negative 4. I'm going to bring down that negative 4. Is greater than or equal to 3 times 2n is 6n. 3 times 7 is a 21. Okay, second step is I look to combine my like terms on both sides. So, on the left side, what can I combine? I can combine the negative 4 and the negative 4 to give me negative 8. So 6n minus 8 is greater than or equal to. Nothing over here I can combine, so I'm just going to recopy that down. Okay, now step 3, if I follow my steps, I'm going to get my variables to one side. So move my variables. Now from here you might notice something already. But I'm going to subtract 6n on this side, subtract 6n on this side. 6n minus 6n cancels out, so I'm left over with negative 8 is greater than or equal to 21. Now, since there's no more variables, I ask myself the question, is this a true or false statement? Negative 8 is greater than or equal to positive 21. This is false. So how many solutions are there? There is no solution at all. Okay. Now at this point right here, you might have noticed that there's no solution because they have the same variables on both sides. So if I really cancel those out, negative 8 is greater than or equal to 21 is a false statement. So that would be no solution at all. Okay. So that's what we are going to finish up with today with your homework. You can keep that out on your desk. You will need a separate piece of paper. So while Miss Osborne's handing out the homework to you, you can get out a piece of paper and head that with your name, 1-6. Today is September 12th, and your period and Friday. And go ahead and fold it in half or draw your line down the middle. So for your homework, 1-6, again, you can have your homework helper book at home to look at 1.6 if you forget what we did in class today when you're at home. So if I'm looking at question 1 through 6, it just says solve the inequality. You don't have to graph this at all, so let's do the first one together. I'm going to solve, so 3f plus 9 is less than 21. I'll go ahead and draw my line down the inequality symbol. No distributive property. Don't have to worry about that. Let me zoom in a little bit for you. Okay, so then the next thing I'm looking for is variables on one side, which is true. So I'm going to get my numbers on the other. So I'm going to subtract 9 on both sides, which leaves me with 3f is less than 21 minus 9, which is 12. I'm going to divide by the coefficient of 3. So I'm left over with f is less than 12 divided by 3 is 4. So f is less than 4 is my answer. Your work needs to be shown on this separate page. And then I'm going to go ahead and put my answer back on the paper. So I have to write f is less than 4. And I'm going to go ahead and circle that to show that that's my final answer. That's what you're doing for 2 through 6. 7 through 10, it says solve the inequality if possible. If the inequality has no solution, write no solution. If there's many solutions, write all real numbers, or in this case, many solutions. It does not matter. So I'll let you write that as well. Now, some of them will just have a solution when you work it out, so not all of them will be no solution or many solutions, so keep that in mind. 11, 12, and 13, you're going to need to show your work on a separate piece of paper. However, these are multiple choice questions, so this is sort of how inequality questions are asked on the EOC. Pretty straightforward. And then the back is sort of your open response questions. You're going to be writing a little bit about explaining to a friend that's having difficulty solving this problem what steps to use. Okay, this doesn't need to be in complete sentences. It could be bullet points, but make sure you're detailed on the full explanation and so forth, and make sure you read the rest. So 16 questions. Go ahead and start after this video is done. Whatever you don't finish is your homework, and it will be due first thing in the homework hotspot tomorrow. Have a great day.